Okay, so we're going to continue on cubed root functions from yesterday. I want you to give that problem a go. Go ahead and work on it on your own paper. Okay, so using our graphing calculator on this one. Okay. 62.5. If you're doing the cubed root, it's under math. You go down to option 4. And then t is just your x value. Okay, so for those of you still remember, math is your cubed root. It's option 4. Okay. And then the t is just going to be x. We're just going to use x there. And then plus 75.8. If your cursor is still under the cubed root symbol, you've got to just arrow over. You finish your parenthesis there. Oops. I'm not going to put the print. Hold on. I don't know how the parenthesis got there. Alright. Let's go with that. Okay. And then if you're graphing it, you're trying to find 200 centimeters where that's our height, so that's our y value. Okay, so if we go to our table, we want 200 centimeters for y. Looks like it would be about 8 inches. Or 8 years old. Okay. About 8 years old.
I'm 8 inches old.
Would you plug that into the equation and then solve it, or is that the
No, that's our solution. Yeah. So that means when x is 8, if we were to put 8 in for t, it would be 200.8. So it would be just over 208 inches. Or 200 inches. Yeah. Okay? I could look at the calculator. Please take out yesterday's assignment. There's problems 1 through 6 on page 315. Should have graphed each of those. I want you to compare them with your neighbors. Okay, any questions on 1 through 3? I actually put up the graphs for 1 through 3. Okay. Now I actually have the tables up there as well. You didn't have to have the tables if you use your the transformations, but this one was a translation 2 up of f. This one was a vertical stretch by a factor of 4 of f. Okay. Questions on 1, 2, and 3? Number 3. Remember your original points would be 1, 1, 1, 0, 0, 1, 1, and then you'd end up with 4, 2, and then the reflections of those, the negative 4, 2, negative 4, negative 2. Okay, so if you are doing a vertical stretch of 4, that means you're stretching this point 4 units or 4 times as much away from the x-axis. So currently it's 1. You've got to multiply that distance of 1 by 4. So it would be a distance of 4. That point would move up to there. This one would move, it's 2, so it would move up a distance of 2 times 4, or 8. So it would be like way up here. That's why we don't see it. This one's 1 away here, so you go down. Same thing here. This one would be way down here. Okay. All right. There are 4, 5, and 6. Number 4, translation 3 units right and a reflection in the x-axis. 5, vertical stretch by a factor of 2, translation 1 down. And 6 is a horizontal shrink by a factor of 1/6. A reflection in the y-axis, and then a translation 2 down. Okay, so questions on those? Yeah? Like here? Remember, it's kind of backwards in here. So when it says you're multiplying by 6, you take the reciprocal of that, and that's what you're shrinking. Inside, it's backwards. Kellen asked me to work through this one. I think it's probably a good one to go through. Okay. Anyone else want to see that one? Okay. Just so you know, the ones we're doing here in a minute are those, and there's a lot of different things going on. Okay, so we have to have the basic ones down first. So this one right here. So we've got our x and y axis. Remember, we're still going to put our normal points, or 1, 1, or 0, 0, 1, 1, and 4, 2, or not 4, 2. I think I said that earlier. That's not actually. It'd actually be there. Okay, so you guys remember your perfect cubes, just so we know what we're talking about. We're saying when x is 1, actually let's start with 0. When x is 0, the cubed root of x, the cubed root of 0 is 0. Okay? The cubed root of x is 0. When x is 1, the cubed root of 1 is 1. When x is, what's the next perfect cube? I was saying 4, but it's not 4, it's 8. I was thinking square root. So when x is 8, the cubed root of 8 is 2. Okay? And then you could also do these in negative. So you'd have -1, -1, and -8, -2. Okay? These are the coordinates you're plotting. 0, 0, 1, 1, 8, 2, -1, -1, and -8, -2. Alright, so I've got 0, 0, 1, 1, and -1, -1. Okay, well, on this graph, the 8 won't work. It won't fit. Okay, if I'm going to keep it a scale of 1. So I'm just going to plot those right now. And those are the ones I'm going to move. Okay, I'm going to take this. I'm going to start on the inside here. And the first thing I'm going to do is deal with the 6. The 6 is on the inside, so it's a horizontal. Okay. It's horizontal, and it's a horizontal shrink because it's opposite. So usually when you multiply by 6, it'd be a stretch on the outside, but on the inside it's a shrink, and you take the reciprocal of that by a factor of 1/6. Okay, so this point that's at 1 would actually be 1/6. Okay, which when we're shrinking horizontally, are we shrinking towards x or are we shrinking towards y? So which one changes it horizontally if I move this way or that way? So yeah, we go towards the y. So if we move this way, that's 1/6. It's kind of really tough to see. You're shrinking into there. So that first shrink is going to about right there. Thank you. Okay. And then from there we're going to go ahead and reflect it in the x-axis or the y-axis. Do I reflect over x or do I reflect over y if I'm on the inside? Yeah, we're reflecting in the y. Okay, so this point moves over to here, and that point moves over to there. So somehow keeping track of your points here. Yesterday we used the numbers. That kind of helped out. So like that would be a negative sign. That's the reflection. This would have been a 6. That was dealing with the 6. Okay, so this was our times 6. This was our negative. The last one is -2. -2 is a translation. Down 2, or 2 down. So this point moves. 1, 2. It's going to be down here. It's actually going to be right there. And this one moves right to there. And this one moves right to there. On the graph I showed you earlier, I had changed the scale on it. But that is our graph there. Should be a lot narrower than what I showed a minute ago. Just to change that scale. It's going to be scrunched horizontally. Cool. All right. Hey, I want you guys to go ahead and take a look at this guy right here. Number 7. Actually, let's not do 7. Let's do number 8. Okay. On number 8, I want you to work with your partner. Okay. Get that one graph, number 8. Guys, this last graph we had should have curved like this, by the way. I had it curved in the wrong way. I know, that's ridiculous.
Oh, silly.
I know. Should have curved out like this. My bad.
You lost the point.
That's from doing tangent last period, dealing with tangent graphs earlier. That's my excuse. But anyway, there was a good excuse.
And then -4, so that'd be. What's the 2 would be -2, so you move everything down to 2. So, like, it'd be like this. And then the -4, so it'd be -2 times 4, -8, but that would be way down there.
So your original points would move down to because of this number 8.
Yeah, because it's like opposite, so it's x minus 2. And then you have to deal with the -4 next, which would be you would have to multiply everything by 4. So by -4. So -1, -4. So that's like the only dot that will be there. Let's ask him like where we need to put that. So it's all gonna be like way down here. So maybe just like. Let me see here. Like this, maybe. Like that. Maybe.
How far down is the
The -4.
how far?
Okay, so.
Good. I've seen some of you start walking around there. I've seen some of you start them there. That's a good start. Getting your axes in. Okay.
Wouldn't it be above? So like the x would be above, like higher up.
Your coordinate is, yeah. But hey, let's start right here. Remember the coordinates you're using. Stay with me, please. -8, -2. That's one of our coordinates.
Oh yeah.
Okay. -1, -1. 0, 0. 1, 1. 8, 2. Okay, so our parent function, we start 0, 0. We get our 1, 1. Not going to get 8, 2 on there. There's that one. If I go -1, -2, -3, -4, -5, 6, 7, 8 would be like over here somewhere. Be down there. And this one, 5, 6-ish. 7, and then 8 would be okay. So that would be right around there. We want to use those points for later. Okay, but there we've got it. We are now taking this. It's on the inside. Remember, when you are adding on the inside, first the inside is a horizontal. When you add, Is it a translation, reflection, or stretch, shrink? Good. It's translation. Horizontal translation. You have your notes from yesterday. Hopefully you use those. It's backwards, so it says +2, which usually would be going to the right, so we have to go translation left 2. So this point goes back 2. It's now there. This one goes back 2. This one goes back 2. This one actually drops back 2 as well. I'm not going to use this one because it's going to even go further over, so I'm just going to get rid of that for now. Okay? And then I deal with the 4. So this was the +2. The times 4 happens on the outside, so it is vertical. And it is greater than 1, so it's a stretch by a factor of 4. So that means all those points are being stretched away from the x-axis 4 times the distance they currently are. So this point that currently is 2 away, a distance of 2, would have to be a distance of 2 times 4, or 8. So that would be up to there. Okay, that would be our times 4, so maybe I'll put a 4 right there. This point right here, right here, that is currently 1 away, would now go 1 times 4, or 4 away. 1, 2, 3, 4, so it would be right there. This point that's currently on would stay right there on. It just, okay, if it's on the x-axis, it doesn't move. And this one that's currently 1 away would become 2 away. So it went from there to there. It was 1 away, now it's 2 away. The negative is a reflection. And since it's dealing with vertical, is it reflecting over x or over y? Thank you. Okay, so we need to make a note on that because that seems to be the question where there's crickets. Okay, if you are reflecting vertically, you are changing your y values, means you're reflecting over the x-axis. What's that? Reflection over x. This point that's right here would now be up here. This point that's right here would be way down here. Okay, so it's currently 1, 2, 3. It's 4 away, so it'd be actually 4 below now. So it'd be way down here.
This graph is too small.
Yeah, this graph. Well, you get better graphs usually, but I'm going to put it right there. Okay? So that would be that point. This point's not going to appear down here. We're not going to plot it. So right now we're dealing with 3 points we still have on our graph. That one, and that one. Last piece is the +3. Is it vertical or horizontal?
Horizontal. Oh wait, no, vertical.
Vertical. Vertical translation. 3 up. So all these points are moving up 3. So 1, 2, 3. That would be right there. 1, 2, 3. There. There. Our final graph. Final graph, the vertex went from here to there. This kind of should be curved a bit more. A lot of different things you're doing there. Okay, we've practiced a lot of graphing. I'm going to be done practicing that with you. Okay, I want you to move on to number 10. Last one we're going to do together as a class is number 10. Graph of a cube root function g is shown. Compare the average rate of change. Talk to your neighbor about what rate of change means. Hey, rate of change is slope, right? Change in y over change in x. We call that delta y delta x. Okay? So the average rate of change of g to the average rate of change of h. Here's h of x. This is the graph of g of x. So if I'm going from 0 to 8, what's my rate of change for x? All right. Tell your neighbor what your rate of change is going to be for x and for y on each of those. How is x changing? How is y changing? Seriously, like babysitting every day with you guys. Golly, man. All right. What is x? All right. If I'm going from 0 to 8, how far am I changing? 8. Okay? That's the same on each of them. When I plug in 0 to h of x, that's 2 times the cubed root of 0. So when x equals 0, we get that. What's that value? Cubed root of 0 is? 0 times 2. Okay? And then we also need to calculate 8. When I put 8 in, everyone figure out what we get there. We get 4 out. So how much did we change from 0 to 8 on y? 4. Okay? So our rate of change is 4/8 or 1/2. All right, they're saying compare it. So now we go to this one. Well, now we look at our graph. When x was 0, what was y? 0. When x is 8, what's y? Y is not 4. It's 8. So we go from 0 to 8. So it's 8, which is 1. So the average rate of change here is 1/2. The average rate of change here is 1. It says compare the average rates of change, well, of g to h. So if g is 1 and h is 1/2, this one is how much bigger than that one? Yeah. How many halves fit into one?
2.
2. 2 times as big. So g is twice as big, or 2 times greater. All right.